Hello everyone. Today we are going to discuss the first problem of AtCoder regular contest 171, which is no attacking. So the problem is what? We are given a chessboard of n cross n, and we will be having a rooks and b pawns. So there are some conditions in which cases we can put the rook at the I comma j position, and in which cases we can put I comma j position at a pawn at I comma j position. So what are the conditions? So for placing a rook, the row and column in which we are placing the rook should be empty, and for placing a pawn at some position, the let's say this is a chessboard, right? Let's say this is a chessboard. So for placing a rook, let's say we are placing some rook here, so this row and this column should not have any pieces. And for placing some pawn, right, for placing some pawn in this position, this should be empty, the the top cell, you can say. So what we have to check is that we can arrange this a rooks and b pawns in the n cross n chessboard, and we are also given 10 to the power 5 test cases. So how we can solve this problem? So for solving this problem, so let's look at the time complexity first. So here are the constants: t is 10 to the power 5 and n is 10 to the power 4. So obviously order of n is also not allowed, so we have to solve something like order of log n or some order of constant time complexity, or order of 1, you can say. So how we can solve this problem, right? So the initial approach that came to my mind is like that. Okay, so my initial thought process, let me discuss with you. So I was thinking that, let's say we have something like this, a 5 cross 5 chessboard, and we have to place two rooks. So I thought that placing the first rook here and placing the second rook here, and we'll be marking these two cells. Now we'll be left with some 3 cross 3 square, and from the 3 cross 3 square we'll be putting all the pawns in the first row and all the pawns in the third row. So we'll be having 6 pawns. But this approach is not what we can say optimal. So why it is not optimal? Here, let's say let me show you the solution approach directly, how we can place the rooks, and that will be beneficial. So let me draw the 5 cross 5 chessboard again. Okay, 5 cross 5 chessboard again. So we'll be placing the first rook at this position. Okay, sorry, not this position, at this position, and we'll be placing the second rook at this position. Now we are left with three we can't place it here, we have to place it here. So where we can place the remaining pawns? We can place the first pawn here, second pawn here, third pawn here, second 6 and 7 8 9. Okay, 7 8 9. So we can place 9 pawns, but here we can only put 6 pawns. So here you can see that why the second case is optimal. Okay, so what we are doing here is that let's say we have a number of rooks, right? So we'll be placing them with one row, alternate rows. Okay, alternate rows. So the first row will be for pawns, second row will be for rooks, third row will be for pawns, fourth will be for rooks. Now let's say here it is 5, but let's say here there are more number of rows, there are more two rows. Okay, for the remaining two rows we'll be taking our initial approach. For the first approach, what we are doing, so we'll be placing the rest of the pawns here. Okay, rest of the pawns here. So for we'll be taking one row and putting all the pawns there, and then rook, then pawn. That's why because we were wasting one row here, but when we are getting, like, here you can see that there is a gap in row between two set of pawns. Okay, so instead of wasting that row, we can put the rook there, right? So I hope you get it. So this is the optimal case, where for we'll place pawns and rooks in alternate rows, and after the placing of the rooks are done, we'll put all the remaining pawns in the rest square with n square by 2, kind of that. Okay, so we'll be checking that the number of pawns we can put is greater than equals to b or not. If yes, then the answer will be yes, otherwise the answer will be no. Okay, so let's jump into the code. So here if n is greater than if n is lesser than a, That means the number of rooks are less than greater than n, then the answer will be obviously no. If it is greater than equals to a, then we'll take what are the remaining number of cells. Okay, and q is the number of pawns. Let's say q is the number of these rows. Okay, number of internal rows between rooks. So there are if there are two rooks, then there will be only two rows. Okay, okay, and there will be okay, so q will be minimum of a comma n minus a. Let's say there are three rooks, then we can't put three set of pawns, right? We have to only place two pawns, two set of pawns, right? So there are so for every internal row, let me call these as internal rows, and these are external rows. For every internal rows there will be n minus a number of pawns, and the number of internal rows is nothing but q. So n minus is a is our p, so we'll be having p into q for the internal rows. And for the external rows there are there are what there are n minus p, sorry, n minus a. So there are p minus q number of rows, and for every p minus q number of rows, so what are the number of rows we can choose? We can choose p minus q plus 1 by 2. This is let's say there are five rows here, five external rows, then we can put the pawns in three rows. That's why we are taking p minus q plus 1 by 2 number of rows, and for in each row we can place p number of pawns, so p into p minus q plus 1 by 2. So that's what I am doing here. Okay, we are printing yes if c is greater than equals to b, otherwise we are printing no. I hope you understand the explanation. If you like the video, please like this video and subscribe to the channel. If you find this video helpful, please consider sharing. um, Thank you for watching.